Okay, we're back, we're live. It's 1 o'clock on a Monday. This is our third show of the day. We're having a wonderful time today, talking to all these great people. And I am not kidding when I tell you that Margo Edwards is a great person, who I have known for several years. She's a scientist. Look at her. A little close up now. That's a scientist. That's a scientist.
All right.
All right.
Okay.
Then can you give us a little bio of your life and times as a scientist, Margo?
Sure. I started out at Washington University in St. Louis for my undergraduate and master's degree. I was interested in...
That's a very, very good school.
Interested in actually space studies. And then I went to Lamont Doherty. It was then Geological Observatory. It's now Earth Observatory, which is part of Columbia University, and started studying the aquanaut part, the astronaut part, the aquanaut part. And I literally defended my thesis on June 21st and got on the plane on June 22nd and started the job in Hawaii on July 1st. So I've been
That's
here.
what I call commitment.
Yeah, ever since. Been here ever since.
Here's what I've been doing since.
Well, I've worked on a variety of problems. Mostly my expertise is seafloor mapping, so I've gone out and made lots of maps of the seafloor.
Qu'est-ce que c'est, seafloor mapping?
Basically, you're using sound to figure out how far away and how reflective the bottom of the ocean is, right? So you're on a ship and you make a ping like in a
radar.
Yeah, like in a movie. You've seen the submarines pinging each other, pings down, and you get a reflection back, and you measure the time that it takes and the intensity, and that tells you a whole lot about what's on the seafloor. Yeah. So I've done that all over, actually. The only ocean I haven't been to is the Southern Ocean, but I've been to every other major ocean, including the Arctic.
Where is the Southern Ocean?
It's sort of all around Antarctica.
Oh, it's north of Antarctica.
Yeah.
Yeah. It's big.
It's very big.
Yeah. What did I hear recently? That a huge percentage of our freshwater, the world's freshwater supply is in Antarctica,
That's
in
true.
the ice there.
Yeah, it's tied up in the ice.
And if we lose that ice, we lose our access. We lose that fresh water, yeah?
Yes, we do. And our sea level rises a lot, too. Yeah, I think Chip Fletcher was down here.
Yes.
Talking about that.
And I keep thinking that the ThinkTech ought to cover climate change on an almost daily basis.
I
Because
think
it's
that
happening.
would be a great thing.
Yeah. I mean, it's like, bad weather. Everybody says, oh, it's bad weather.
Yeah.
No, it's not. It's climate change, man. And, right, all this drama is happening, so much of it. You can agree or disagree. I don't know.
No, I agree. I do think we need to separate the difference between weather and climate. That's why we have people showing up with snowballs and saying, see, it's not getting warmer, but we need to look at the long-term picture. But I think that everybody's becoming convinced that there's something really going on.
Yeah.
And I would commend your efforts to cover climate change every day.
Every day.
I think that would be
Yeah,
fabulous.
like the climate change report.
Yeah.
Like news.
Okay.
It is news every day.
All right.
I just have to find people who come and talk about it with me.
Sign
okay?
up. You can
okay,
do it.
I got
All right.
that.
Okay.
You can do it on the phone or by Skype, okay?
Yeah.
And wherever you are in the world, even in the Southern Ocean, we'll find you.
Okay. All right. Okay. I'll call in.
So talk about, that's where I think, I was talking before with you about where we met, and it was at P.J. Chang.
Right. P.F. Chang.
P.F. Chang.
Right.
Oh, it wasn't
endorsement. Right.
And you were talking to the Science Cafe,
Right.
which is part of the Hawaii Academy of Science, I think.
Yes.
And I was there, and I was so taken by your remarks that evening. And you were talking about your work on the munitions just to the south of Oahu that were dumped there by the Navy.
Army.
Army.
It was
Okay.
the Army.
Army.
Yep.
Using Navy ships or using Army ships?
Using tugboats, actually, mostly tugboats and barges.
Yeah. So after the war, not too far after the war.
Right. Actually, 1944, 1945.
During the war.
Yeah, right at the end of the war, a whole bunch of obsolete munitions, excess, obsolete, and captured, were taken out to sea and disposed. We don't actually know how many. We know a ballpark tonnage, about 3,000 tons, which sounds like a lot until you realize that in the Baltic Sea, north of Germany, they have 300,000 tons
Of munitions in the water. Wow.
It's a global problem. And I'm specifically looking for munitions that have chemical agent mustard on the inside of them.
But it'd be all kinds, I guess.
Yeah, well, we found all kinds. We found everything from, 50 caliber rounds up through big, large Navy torpedoes.
And I don't want to say lucky, but the interesting thing about this is that when they dropped this off the fantail of those ships, they dropped it in a pattern, kind of like a pattern you'd take when you're doing depth charges. So that actually made it easy. See how I remember this?
I'm glad.
So that made it easier for you to find the patterns of the dropping courses. So you could identify changes in the sand down at the bottom, right? Tell me.
That's exactly right. I mean, basically think of it as Hansel and Gretel, except instead of dropping breadcrumbs, they're dropping so heavy that the birds can't come and take it away, right? And so you have these little trails of breadcrumbs that are these munitions that were disposed at sea. And it was finding those trails that sort of gave us the big insights. You know, some of the insights in retrospect, they seem obvious. Because munitions would have been stored in a warehouse by type. If you go to one of those trails of breadcrumbs, it's pretty much all one type of munition, and then you move over to the next one and it's a different type of munition. The ones that were easier to throw over the side or close together and scattered, a little bit, they look kind of fuzzy, and the ones that were really heavy or spaced more further apart.
And you could learn how this works and thus identify what.
And we really had to do that because nobody documented what was happening at that time. I mean, the major documentation that we had was go 5 miles south of Oahu and dump these things.
5 miles is only a very short distance. So should we be worried about the mustard gas? I don't get along with mustard. I like mustard on my hot dogs, but that's about as far as it goes.
Well, so what we're finding is we went down and we collected sediment samples. We actually pulled a kind of a starfish right off the munitions, and we examined all of this stuff. And we found mustard in a sort of parts per million. 10 parts per million was about the highest that we saw. But then that was when we were going down there with the Pisces submersibles. So we had people and we were being very careful.
From Snug Harbor, yeah.
Right.
Yeah.
And so this last time we went out with the Jason remotely operated vehicle, ROV, from Woods Hole Oceanographic. And we literally dug into the munitions and we brought that stuff up. And what we found in that case was actually higher concentrations of mustard, to the point that we actually brought live agent up on board the ship. Now, we're lucky because we had the team from the Army that was there that deals with chemical agent and
They
places.
knew what to do.
They knew exactly what to do, and they did it very well. And they kept all of us safe, and when I say we had live mustard on board, I could send you a picture, but basically you have to think of like an equal packet, and that's how much live agent we had on board from digging right into these munitions. But there still is a little bit of it there. And so the other question is, what's going to happen when it disintegrates? Many of these munitions, if I touch them like that, I don't have to hit them.
It's already half rusted anyway.
Yeah, they just sort of go poof, right?
And then they're in the seawater.
Right. So they're pretty far underwater. They're like 1,500, 1,800 feet underwater, right? Not where you and I are swimming and diving, but that stuff. Is it sort of a pillar of salt erosion that happens naturally, or is there this little burst of stuff that gets released into the water column? And that's the question we don't know the answer to yet.
Yeah, so, this is a problem not yet quite solved. You found it, you know where it is, and you got maps, that's, I guess, the point.
Right.
But there still remains what to do.
Right. What's going to happen in the future, I think, is the $64,000 question.
And the larger question, too, is this is an example of what happens when you make munitions and you don't know what to do with them.
Right.
And they have a kind of half-life for years and years and years and years afterward. And they are dangerous, and they get in the way of everything.
So here's an interesting anecdote on that. I went to Germany last October, and I was in Kiel, and they took me to see their place where they're disposing of World War II era munitions. And it was sort of, little room after little room after little room. And I finally asked the obvious question, which is, how much of this stuff do you guys find? On land in Germany, they find, in Kiel, which is one of a few states in Germany, they find 2 munitions per day 70 years later. Are you kidding me? And we have so much more that's in the ocean, so yeah, I'm a huge proponent of, we got the Office for the Prohibition of chemical warfare. We got to stop building this stuff. And
The war that keeps giving. I think people don't realize that you don't use it all up in a war. And when the war is done, you still have a lot of it around, and it's still lethal.
right.
And it reminds me, by the way, this is really interesting, that this is 60 Minutes, I think, years ago, was about nuclear materials in Russia, because they were making bombs.
Mm-hmm.
We may have the same issue here, except they were sloppy in Russia. And the issue was, who is actually in control? This is after the fall of the Soviet Union. Who is in control of these nuclear materials and bombs all around Russia? And they went looking, and they found that some of them were behind padlocks in old barns, where with a hammer you could get right in there and get access to a nuclear bomb.
It's scary.
It's scary.
It is.
And I mean, I think the world is loaded with this kind of thing, and it's may I say, a time bomb.
It can be.
Yeah.
People get hurt, you know. People still get hurt.
And then I saw you on the waterfront. And you were a principal investigator of some technology involving a harbor remote device, which was so impressive to me. And it went all around the harbor, and it tested the water for various things and bad agents and the like. And it was anti-terrorism device mostly, eh?
Yeah, well, it could be used for anti-terrorism. It could be used for a lot of things. First, I got to correct you. So Brian Bingham is the guy who invented
yes,
this.
right. I met him that day also.
Yeah, and he's I think a real rising star in the field of marine robotics. And I'm the person that wants to use it, right? And I've been trying to help shepherd it so that we're actually trying to get it to be transitioned. We've been working with, I don't know, can I say the company? Battelle, to try and convince them that we really need to start producing these things. So yes, it could be used, like if you wanted to go survey piers and pilings and see if anybody had stuck any new thing on there, it would be an excellent tool for that. What it was really developed for was, you remember in Fukushima when all the wave came in and then it just picked up these cars and it pulled all the cars back into the harbor. So if you're in the Coast Guard and you're trying to get in there to help people, all of a sudden there's all this debris and stuff that could create another catastrophe that's been moved out to the harbor that wasn't there before. So this thing has a draft that's really shallow, and the idea was to be able to drive it in there so that it could make a map, again, map of the seafloor, map of the harbor bottom, and see where all the debris was so that your ship could move in there safely. But it can also do chemical sniffing, you can put cameras on it.
And it was modular. You could add new sensors when new sensors became available, right?
Yeah.
The thing was about, I'd say, what, 6 feet maybe by 4 feet, something like that?
Yeah, a little bit longer than that.
Well,
but
okay, 8 feet.
Two people can throw it in the water. 2 graduate students can throw it in the water.
That's what they're good for, these graduate students.
Yeah, exactly.
And it had all these sensors, all kinds of sensors, top and bottom and
And
sides.
it's got a little GPS, so it knows exactly where it is, and it's
Yeah.
sending the data back over a cell phone connection, you know. It's a sweet little system.
I was very impressed with that. I said to myself, they don't have it elsewhere, really. And we had developed it right here in Manoa.
Mm-hmm.
And it was obviously of use and would be of greater use as time went on. It was just a great concept, and it'll be useful going down. So that's why they should manufacture it.
Well, and so what we're going to be doing for the next few months around the island is taking it around and trying to do little pilot projects so that we can get people feeling more comfortable, people, the state, people, federal folks who might be interested in waterways, you know, just what could you do with this? And then I'm going to come back and show you our portfolio of all the cool things that we did, all right?
Yeah.
All right.
Yes, please, right here, this
Okay.
chair.
All right.
But it also opens up the whole issue, just before we take this break, I want to raise, it's, you know, so many autonomous vehicles are being developed now, underwater, on the surface of the water, in the air. I mean, it doesn't quit. We have a regular show on drones that doesn't quit. And the technology that you develop in one of these areas of activity is useful maybe in one of the other areas of activity.
Yep.
We're going to find ourselves, in our lifetime, in 5-10 years, we're going to find ourselves surrounded with autonomous vehicles. And the question is, how good is the software?
Yeah, well, Brian's software is excellent. So one of the things he did very recently was a tandem exercise over by Mackay Pier, over by Sea Life Park. And he had his two little vessels, he's got two of them now, fallen one after another, and monitoring dye that had been put, non-environmental impact dye, that had been put into the ocean there, so that, you know, next time there's a chemical spill, he can send these two guys out and they can figure out what's going on with the spill, the plume as it moves across the ocean.
Including molasses, even.
Including molasses.
And they can talk to each other, and they can form a swarm, if you like, all coordinated.
You're thinking in my head.
Sorry. Okay, that's Margo Edwards. She's actually the executive director right now of UARC, which is, what does that stand for? Let me think. It's, I forgot.
University Affiliated Research Center.
UARC. Okay, and we'll talk more about that when we come back here on Research in Manoa.
Ted Ralston, folks, host of our show at ThinkTech Hawaii called Where the Road Leads, where we talk about technology influencing the future of Hawaii. Technology, of course, is the art of solving problems. We always bring in interesting and informed guests who can see from different perspectives and different points of view how that future might unfold and how technology can assist us in getting there. So once again, join us 4 o'clock to 5 o'clock on Fridays. Ted Ralston, your host. And please, if you have ideas that you'd like us to address on this show, or folks who you think should be on it, let us know.
Aloha, I'm Carlos Juarez, host of Global Connections, and I want to invite you to come join us. We cover a range of global issues. We bring a lot of expert opinion, a lot of issues, whether they're contemporary events happening in the world or maybe looking at things from a more historical perspective. Global issues, very important for us to understand in this globally interconnected world. Join us here on Global Connections.
Well, and that's what...
Yeah. We're back, but we're having a great conversation during the break. We're talking about drones, among other things. Okay, so Margo, let's talk about UARC, okay. University Affiliated Research
Center.
Okay, and there's not that many of them?
There's a dozen of them within the Department of Defense. There
Okay.
are 5 within the Navy.
And it was started, let me make a guess and say it was started around in Hawaii, 2003 or 4, like that.
2008, actually.
2008,
Yeah.
okay. And I remember telling you beforehand, you know, there was a controversy about it because it was supposed to include classified research, and it was going to be DOD, and there were students who got all excited, and they went and they occupied David McLean's office. He was the president of the university at the time, and they brought McDonald's there, and they had all kinds of fast food around, and nobody ever took out the fast food boxes. And after 3 or 4 days, it was really special. So I was doing a radio show for Hawaii Public Radio at the time. I thought this was interesting, so I sent one of the interns to David McLean's office with a recorder, and I just asked them all one question: why are you here? Exactly what are you protesting? And I got such muddle back because nobody really knew why they were there. And as it worked out, it really wasn't threatening, and it wasn't worth a controversy. And now it's settled down from 2008 to now 7 years later. It sounds like it's a very worthy effort by the university and by you.
I certainly think so. So I've only been in charge for about 5 months now, but you know, we were finding our feet, and I think that was part of the concern in, you know, the early 2000s is what is this going to be? And it took a while, to be fair, you know, for us to figure out what it was that we were going to do. But, you know, all of the previous UARCs had been stood up pretty close to the end of the Navy UARCs, had been stood up, created at the end of World War II. And, you know, so they did sort of what you think of as World War II kind of things. They were manufacturing torpedoes, or they were doing acoustics to detect submarines, you know, sort of the Cold War kind of stuff. And I'm not saying that they haven't, you know, progressed as technology has progressed. They're doing fabulous things, but each of them sort of settled on a specialty. And one of the things that the Navy said to us right away is, you know, you need to find where your niche is. What is it that you're going to do that doesn't just replicate?
You meaning you, or you meaning UH?
The UARC.
The UARC at UH.
Right.
Because they all have a different approach.
They all have a different sort of, we call them core competencies. We all have different things that we're supposed to be really good at.
Yeah.
So, the obvious one that we're doing that none of the other UARCs had started because we weren't even thinking about it at that time is renewable energy. So recently I think people may have seen that there was this WETS, wave energy test site that was set up over at Kaneohe Bay.
Oh, sure, we've had shows on it and all that.
Right,
yeah.
so that's-
Ocean energy, wave energy.
Right, so that's something that the UARC is funding. We're evaluating different systems for the Navy to see if they're effective uses of wave energy. We've got 2 projects that are looking at developing smart grid technology for naval bases. All of that can potentially translate to broader Hawaii and broader U.S.
Now, what's the difference between this and dual use?
I don't think there is a difference. I mean, if you have a technology that you develop for, a DoD application that can translate to almost instantly to the private sector and vice versa, that's what I always think of as dual use.
So what you do now can be used in the private sector. It's not hidden under, some kind of cloud of mystery. If you invent some kind of technology, some kind of science about, the grid, some kind of inverter mechanism, who knows what, that can be put into the civilian community without any, the government's not going to claim it or stop it. Yeah.
That's correct. The exception to that might be cybersecurity. And so this is another area where we're really starting to get into, and this is all 5 of the Navy UARCs are starting to get into something that's so new and so rapidly evolving that it's kind of tricky. And there's a potential, I guess, that you could develop some sort of cyber blocking system to prevent any hacker from ever getting into your computer. And that might become classified.
I want that. I want you to develop that and use it. You have my complete blessing.
Thanks. We're working on it.
Just trying to be helpful.
We're trying to get together with a lot of people, including on the mainland, to solve this. This is a huge problem. I honestly, I think sometimes that if people of my kids' generation knew what potential pitfalls there are with having so much information online, they'd take down their pages.
Yeah, well, there was a thing on 60 Minutes about the Sony episode, which was very scary because they targeted the company and they very nearly brought the company down from North Korea, pretty clear it was. And they did that with relative impunity. And there's no, global organization that could really step in. And so you want the U.S. to have the capability of doing that and more. But what it suggests is we are in a global effort at cyber war, whatever you want to call it. And we have to participate in that, or we'll be at the wrong end of we'll be a victim. Yeah.
I agree.
Yeah. Well, that's really interesting. And to have that happen in Hawaii is great. We have the ability at Manoa. We have all kinds of abilities there.
So one of the really nice things that we have in Hawaii, but it's also a scary thing, it's sort of a dual-edged sword, is because we're so isolated. If you're New York or you're Los Angeles or, pick any city on the mainland, you can go in so many different directions with your information flow. In Hawaii, because of these cable landings that we have, we're really limited. So that, it makes us a really terrific test case. We can be very isolated from everybody else and see what's coming in from where and think about how we're going to deal with stopping that pathway right there, right? But it also...
On the cable.
Right.
That's really interesting, yeah.
But the other thing is it means we're incredibly vulnerable, right? We only have a few pathways where information comes in and goes out.
If it's blocked, then we're blocked.
That's right.
Yeah, it's great vulnerability too, not to have internet. I remember, the 60 Minutes story. They love this stuff. It was about an American utility company that ordered some circuit boards from China. And the circuit boards came back with a little piggyback affair on it. And the guy said, wait a minute, that piggyback affair is not part of the specs. That magically appeared on the circuit boards that were being manufactured in China. And they didn't know exactly what the piggyback thing did, but they knew it was not what they ordered.
Yeah.
And so you say, this is dangerous business. Because, if you're looking for mission critical, utility companies, and power generation is mission critical for everyone. You know?
And, that's what we sort of saw with Russia and the Ukraine. If you put somebody's power out of business and you stop their water treatment plants from working, right, in about, like you were saying about President McLean's office, in a week, they're a lot more amenable to people coming in and saying, we're taking over, okay, because it's miserable here now.
Yeah, because your civilization has been undermined and you can't do your daily life. And so people take it for granted that we'll always have the lights, but there's a lot of reasons, a lot of vulnerabilities about the lights. So this is very important. There was a Japanese speaker, an expert in cyber terrorism, came out from Japan about 8 months ago, and spoke about the worst case analysis, and he made it clear to everyone that you could bring a given society down with cyber terrorism. You could hit the right or the wrong things and make everything stop. So it's critical.
It is.
Yeah. What else you doing?
So on September 1st, maybe you saw that there was a press release at UH, and it was in the paper too, about nuclear non-proliferation. So the physics department at UH has been looking at, trying to figure out where nuclear reactor sources are all over the globe, and that was a big publication that came out.
So is that nuclear for war or peace or both?
Mostly it's coming from reactors, can come from power plants. Mostly it comes from power plants.
And so what the mission is to find them and map them?
That's right. They produced a global map of where all your big nuclear sources are.
How interesting.
And they're developing technology that'll make it easier for us to find nuclear sources in smaller portable pieces of equipment, so that, it used to be that you'd have to have something the size of this room to be able to detect its antineutrinos, to be able to detect the antineutrinos. And now they're building it so that it's maybe the size of this table underneath, right? And you can move that around. So if you need to get closer and have higher resolution, you can.
So, and that can look at great distance.
Right now, yes. The systems that they've developed all together can look, everything from meters, tens of meters, to kilometers, tens of kilometers.
So it can see big things and it can see little things. Could it see a nuclear bomb in a backpack?
I don't know that it's ready yet to see the nuclear bomb in the backpack, but that's certainly the question that everybody's asking, in the direction that we want to go, is making it smaller and being able to find smaller and smaller amounts.
Yeah. And then, of course, find new amounts, new things. For example, in Iran, and monitoring Iran, it'd be very interesting to be able to map it on a daily basis or a weekly, whatever interval there is. And any other country that was, at risk of becoming a self-styled nuclear power, we could find out what they were doing that way without non-invasively. That's great technology, important technology.
I think so.
You're saving the world, Margo.
Well, not me. It's all the principal investigators who are doing this excellent research.
Okay, well, tell me how it works. You're the executive director. There are various projects out there. There are various principal investigators. You supervise them.
Right.
Tell me, how does it work?
Well, basically, really what we call it the Applied Research Lab. What it really is an administrative service that helps to connect people at UH who are doing work of interest to the Department of Defense. So we're trying to have we had a half-day session the other day. I called it speed dating, where a whole bunch of researchers got up for 5 minutes and said, here's what it is that I'm working on. And people from the Department of Defense were there taking notes and saying, and so now they're starting to communicate about whether or not, they could work together. Things as simple as corrosion. How do we keep our ships from corroding? Lots of work on acoustics. So, basically what the Applied Research Lab is just the administrative part of getting these folks to be able to work together more easily.
It must be so exciting to be around all of these great projects with these great principal investigators. It must really make your day.
I learn something new every day, and I'm a big fan of lifelong learning, and it's something cool.
So are we,
Yeah.
right here. at this table. Yeah.
But the other thing.
With you.
And, all right. Well, the other thing, I don't know when you're going to have your next break, but, the other idea that I've really been trying to figure out is, can we use the Applied Research Lab to fill this gap? So there's this real big gap that drives me nuts, and you know that it drives me nuts because you've met my kids. We have a lot of companies saying we don't have enough people to be able to do what it is on a technical front. We need more technical workforce to be able to support us. And in the meantime, we're sending all these very smart Hawaiian kids to the mainland because they can't afford to have a job. So one of the ideas that I've been trying to develop.
Now we'll take the break.
All right. Dun, dun, dun.
I want a cliffhanger. It's Margo Edwards. She's the executive director of UARC. That's the university-affiliated research center right here in Manoa. And we're talking about research in Manoa, and we're talking about UARC is alive and well in Manoa.
It is.
We'll be right back.
Aloha, my name is Miley Scarpino, and I'm the host of the Empower Hour. If you're interested in health, nutrition, fitness, here on the island of Oahu, want to learn more about places to train at or different trainers available, then watch my show on Fridays at 3. We have a great time, and I hope that you'll come join us. Much aloha. Now go get swole.
Hi, my name is Stan Osserman, and I host the show every Friday here on ThinkTech Hawaii called Stan the Energy Man. We talk about everything energy, from anaerobic digesters to batteries to hydrogen fuel cell and grid power. And we do that to keep you informed on the latest technology that's out there and the things that are going on in Hawaii. We broadcast every Friday from noon until 1 o'clock, and I hope you'll tune in. So sometimes we'll be on ThinkTech, and sometimes we'll be on Olelo Channel 54, and I'd like you to listen in to me and join me every Friday. We'll see you then. Aloha.
Okay, we're back, we're live. We love talking about science, and we love talking about science with Margo Edwards, no kidding. Real scientist in every way. Okay, so Margo, you talked about the kids, and we left it with a cliffhanger about the kids and how the kids left town but could participate in these great projects. What are your thoughts?
Well, so the idea that we have, and I've actually been approaching some of the businesses, both tech businesses, but like in the case of cyber, you pointed out, non-tech firms need cyber personnel too. How can we develop a program at UH that allows students to intern and get the jobs here in Hawaii already trained? It's very inexpensive for Department of Defense or a bank, right, to fund a student to get a 2-year master's degree to learn how to do cybersecurity. I'm making it up, right? And then they walk into a job with a salary that allows them to stay here in Hawaii and live by their family and raise their kids the same way that they were raised.
Who's going to give them the job?
Well, I'm hoping that, I've been conceiving this crazy idea that I call a virtual mall, because it can't ever be just one entity. For example,
Be an industry or a sector.
It not even that. It needs to be a lot of variety. So, if you think about, again, cyber, if you think about cyber and healthcare, right? There's a whole lot of people in healthcare that would like to protect your records. There's a whole lot of people that would like to protect your financial records. There's a reason to protect your security records. That's NSA and DOD, right? And then there's these little individual companies that are small, that are starting up, that want to latch onto a 20 or a 30-year-old who's the best programmer that they've ever seen. So they need them in 1s and 2s. Maybe DOD needs them in 10s, right? Maybe a bank needs them in 5s. And if we get enough of those people back, enough of those people together, then we build a place that becomes interesting for kids. The question that I keep asking myself is, how come so many kids go live in Mountain View, California, when it's so expensive compared to Hawaii? It's actually more expensive to live close to Google, right, than it is to live here in Hawaii. And software is infinitely transportable. You can do software in Hawaii just like you can do software in California or Boston. So how come these kids aren't coming back? And so I ask, you know, my teenage gang, I ask them and I ask their friends, and it always comes down to the fact that there's a critical mass of people that are doing interesting things that they're attracted to, that they want to go work with that. So I'm thinking that if we can get these sort of flavors of different technical jobs together, there becomes a critical mass of opportunity so that the kids, instead of saying, okay, you know, I'm going to live in California, I'm going to live in Massachusetts, they say, I'm going to live in Hawaii. I'm going to raise my kids the way that I was raised. And I think a lot of people actually really want to do that. They just can't figure out when they're 20 and a house costs as much as a house
So
costs.
what do we need to do to make that happen?
We need to get people saying, I'm going to contribute internships to get these
Companies.
students. Yeah.
And internships means there's jobs. That creates the short-term jobs.
And
anyway.
that's the part. I mean, they have to be willing to follow through, that if a kid, you know, I understand sometimes a kid is just not going to work out. And you're going to say, thank you very much. We had a great summer. We really appreciate what you did. And you're going to move on. But sometimes a kid's going to do 3 things for you that you're going to say, I got to keep that guy. I got to keep that girl, right? And so then you have to follow through and you have to be able to give them the job. I think that all of Hawaii has to come together if we're going to build this tech workforce. It can't be the onesies and twosies. It can't even be the 10s and the 100s. You know, we need to have kids literally in a virtual Ala Moana be able to go down and shop through and see what it is that they like. At the same time that the people in the stores are watching the kids and saying, that one has a pretty good skill set for what it is that I need to do.
Speed dating.
I love it.
You know, short story. May I tell a short story? So I go and make a movie about, let's see, we made this movie in the little classroom there in the Sullivan Center, on the 3rd floor of the Sullivan Center in Iolani. It's a science building.
Mm-hmm.
And Margo was there, and these kids had either just come or gone to Ritsumeikan University in Japan. And so you were one of their mentors, one of their advisors for the program. They loved her. I mean, tears came to your eyes, the comments they made. I will never forget the special relationship you had with them. It wasn't just that you were socially friendly and helpful to them. You were a mentor in the fullest sense of the word, so I'll never forget that. I have it on film, actually.
Well, thanks. You know, it's a pleasure. It is a pleasure to work with Hawaii's kids. And I think that we sometimes lose track of that because, you know, it's easy to look at just a whole bunch of numbers that come from reports of how we did on standardized tests. But when you sit down with Hawaii's kids, and I'm not just talking about Iolani, yeah, I'm lucky that I get to know a lot of Iolani kids, but I've met, you know, because my kids both do robotics, you know, I've met Kalani kids and I've met Waipahu kids, you know, best robotics team, and Iolani's going to get me for that one, but,
No,
you know,
but
they're a terrific robotics
they're all
team.
over the
And
place,
It
and-
is, and, you know, they're just, you know, they're very, very bright, and a lot of them are super motivated to do really well, and then we send them away. Wow.
And they go away forever, and they don't come back, and we lose je ne sais quoi, that special quality that made Barack Obama president, you know, the special Hawaii Island thing. And we got to keep them here. And the only way to keep them here is give them jobs and housing,
Okay,
also housing.
all right, so we're linking arms.
Okay, we can
All
do
right,
that.
all right.
You saw it here on ThinkTech. But I want to go now to fishing, because I know you're working on fishing, and I find that really, really interesting, because fishing is also in sort of in a transformative mode these days, global fishing, a sustainability issue. So what are you doing on fishing?
So this came up a while ago working with Coast Guard and NOAA and sort of wrapping my brain around the fact that there are lots of illegal activities going on with fishing, and it's all about making maps. So instead of making maps of the seafloor, what you do is you make maps of what a boat is doing, how fast it's going, where it's going, even what the shape of the boat's track looks like. And we got involved with a group in Houston, thanks to Kevin Kelly. I don't know if you know Kevin.
I know Kevin very well.
Yeah. And basically the Houston guys are putting a receiver for the vessel tracking. It's called Automatic Identification System, AIS data. They're putting a receiver for this on the International Space Station. And I said to the folks in Houston, you know, if you gave me some of that data for real cheap internships now, I could take some UH students and I could train them how to be the next generation of people that are using computers to try and find these bad guy fishermen. And they bit. And so we have 4 undergraduates working on the project. We just started, when classes started this year. 2 boys and two guys and 2 gals. I shouldn't say boys and girls. They're in their 20s. And, you know, they're wonderful. They're local kids. You know, they're very interested in fishing. And it turns out when you start actually investigating the fishing problem, it's not just fishing, it's human trafficking, you know, it's smuggling, it's all
It's
kinds.
migrant boats that are going to sink in the Mediterranean. It's all of that, yeah.
Right. So these kids are getting a skill that I hope is going to be useful for them if they want to stay in a job in Hawaii, in NOAA fisheries. You know, they want to work with the Coast Guard over at District 14 as a civilian, you know, and they have a skill set that they walk in and they say, you know, okay, I can do that. So that's the goal.
Yeah. Oh, but that's very exciting science on both ends, and it's very exciting for the kids. And we tend to be, again, globally useful, but we got to keep them here. Mm-hmm. We could become, don't you think, the ocean mapping center of the universe?
I think we should be. You know, I think
we're in the ocean.
I think that, you know, Rhode Island, I never really understood that one, but, you know, I mean, we are the island state, you know, we're the ocean experts, and I think that Hawaii, you know, I believe in Hawaii, I always have. I wouldn't have spent so much of my life here if I didn't.
Yeah. Well, don't stop for a minute, but I want to give you an opportunity to speak to the president or the governor. You can take a pick. Let's do the governor for now. Okay, that's the governor's camera over there. That's number 2, and he's listening. He always listens when we put his photo up on the camera.
All right.
So, what would you urge him to do to make these things come true?
I would love to see some sort of statewide initiative that says we're really going to make an effort to invest in working collaboratively that's industry, federal government, state government, educational system, to keep Hawaii's kids working in Hawaii, to develop the internships, to develop the programs so that they can get a real job to afford to buy our houses here and do interesting work with people of their own age, that critical mass. I bet the state would just take off.
Economically.
Economically.
Yeah. And my second question is, what should they do to be like you? What should they do to get your job and eat your lunch?
The kids now we're talking about? Well, you know, obviously I'm passionate about science and mathematics, and I have been forever, you know, and that not every kid has that passion, but lately I've been sort of coming around to the idea of STEAM and not just STEM, and so that the art component is a really important part of this.
You heard it here on ThinkTech.
Oh no, I didn't invent that. Other people invented that. But you know, I think the first thing is I am privileged to be able to do what it is that I love. And I see so many young people that do what they do to be able to make money. And I don't think that that's the way to a successful life. You know, the fact that every day I get up and I feel like I'm doing something good for the planet, you know, something good for the state, something good for this kid today, it just makes it easy to work. And I think if kids can latch on to finding out what it is that they really love and doing it well, whether it's science or art or music, you know, they're going to be happy people.
Some of them might even get your job.
I hope so. I would like some of them to have my job. I'm not planning to do this forever.
I want you to do it forever, though. That's just me speaking. Margo Edwards, the director of UARC, the University-affiliated Research Center in Manoa. We're talking about research in Manoa. We're talking about UARC is alive and well in Manoa, and Margo is there. Thank you so much.
Thank you. It's been a pleasure.